So till now we spoke about bending of light. So when light enters from one medium to another medium, when there's change in optical density, it will bend. But how much bending will we see? Okay, how can we talk about this? How can we express this mathematically? Because physics always does that. We have a concept and we talk about in numerical form. So that is done with the help of relative refractive index. So it is a numerical way of expressing the amount of bending of light when it moves from one medium to another. For example, if I see a value which is 3.2, right? If we see this value, which is a value which is greater than 1, we can tell that the light will bend towards. If I see a value which is again greater than 1, it is again towards. Any value greater than 1, it's towards. Less than 1, it is away from the normal. Okay, the light will bend away from the normal. Anything that is, okay, this is also less than 1. This 2 is away from the normal. But what if it's equal to 1? It's neither towards nor away. Means what? No bending. Okay. So if we see a relative refractive index value which is equal to 1, there is no bending. It is not only this about bending towards or away. We can talk about how much bending also, right? So as of now, we can just tell in layman terms, right? Not going into the mathematics, not talking about the degree. We can tell there will be a lot of bending over here, right? Because 3.2 is much bigger than 1.3. So this is decent amount of bending. When you compare 0.8 and 0.5, there is decent amount of bending over here, and there's a lot of bending over here. And here we need not discuss anything, right? Again, this is the basic information that you can derive by just looking at the values. Okay, so that's what I told over here, that mathematically we can express the bending, and that is nothing but your relative refractive index. Symbolically, we write it as n and 2 stuff. So this is called a subscript. For example, I have here light moving from water to oil. So we have to represent it with n of oil, comma, water. Actually, we read it as relative refractive index of second medium, that is oil, with respect to water. Okay, this is how you write it as. So we always write it, we write the to part first and then write the from part. And this is called a subscript. We won't write it in the same line as your any other sentence. We write it below a given symbol. So this is known as subscript. Okay. So what else? Yeah, one thing you need to understand is you always write the medium which the light goes to, and later on you put a comma and write the medium from which it came from. This is one of the way of writing. Okay. So here the light is moving from water to oil. So this arrow, it will help you guys to remember that we have to write to and then from. Okay. So this is what I've written over here. So one more example over here. The light is moving from oil to glass. So refractive index of glass with respect to oil. Okay, this is how you read it as, and you write it in this order, to and from. Right? Now, to define relative refractive index, we have two ways. One in terms of angles, another in terms of speed. So first one is something which you guys have already seen. So relative refractive index, it is the ratio of, okay, right? So you have two subscript. It is a ratio of sine of angle of incidence. So sine of I divided by sine of angle of refraction, sine of R, for the light of a given color and for a given pair of media. This is how you represent this as. Yes, this is nothing but your Snell's law. So that constant we spoke about in Snell's law, right? We did a particular experiment as well. We got an answer of 1.44 if I remember right. that is nothing but your, that constant is nothing but your relative refractive index of, I think it is air with respect to oil, or water with respect to oil. I forgot. I think it's water with respect to oil. Yeah. So there we got water. No, oil with respect to water. Oil with respect to water. And that was 1.44. Okay. So that constant is nothing but your relative refractive index. Another way of expressing is, it is a ratio of speed of the light in the first medium to the speed of the light in the second medium. That is first medium, okay, second medium, first medium. See here, I have not put comma because we are just representing with numbers. So this is your medium 1 and this is your medium 2. So you can write it as refractive index of oil, comma, water. And always remember, it is in this order, right to left, water to oil. So apparently this value is equal to speed of light in the first medium is water, divided by speed of light in oil. This is another formula, and you can see this too. It is one and the same. Okay, what I mean is, the LHS is same in both the cases. Right? Again, there are different ways of representing. See, I can write it this in this manner as well. 1 divided by 2. Okay, again, all of this can be written in different ways. It's just a way of writing down. You know, if you're looking at specific medium like water and oil, you can write it in this manner. If they're just calling it as medium 1 and medium 2, we can just write 2 and 1. Again, it's left to you guys. You guys can write it in this way also, medium 1, medium 2, medium 1. Right? It's moving from medium 1 to 2. It's left to you guys how you want to write. There's no restriction. Okay, so this is two way of defining relative refractive index. Yes, and you need to know this definition as well. So to summarize, I have light moving from medium 1 to medium 2. You have angle of incidence and angle of refraction. So as per your syllabus, this is how they write it as relative refractive index of medium 2 with respect to medium 1. This arrow part is purely mine, but yes, it helps. So let's continue to write that, is equal to sine of I by sine of R, which is also equal to speed of light in medium 1 by speed of light in medium 2. So people who would like to write in another way, you can do so in this manner. Relative refractive index of medium 2, comma, medium 1 with respect to medium 1 is equal to sine of I by sine of R is equal to speed of light in medium 1 divided by speed of light in medium 2. All this is one and the same. You need not worry. Everything is right. Okay. So left to you guys what kind of representation you want to have. Don't be scared. All of it is right. It's just a representation. It's okay. But yes, you guys have to write all of this down and understand and remember. Okay. So it's just a representation. You will not learn anything fancy. There's simple definitions. It's just simple ratios. Right? There are two definitions. They're basically two ratios. One is related to Snell's law, another related to speed of light. Right? That's it. So please pause and copy all of it.